The fourth reason why steel is weird is that natural ceramic. You see in the textbooks this drawn as your structure, with the triangle out here. This is your phase diagram of steel. That's 1150 degrees C. That's 723 degrees C. I'll just take that out there. That's 900 degrees C. That's 0.08, usually 0.03, something like that. Down here is 0.008. That's 0.8% carbon. So that's really your graph. Now let's draw over the top of this to scale. Or we'll draw it over here. There's 1, there's 2%, there's 250, 500, 750, 1000, 1250. Let's draw this to scale now. There's 950, 900, there is 1150, there is 723. There's 0.5, there's 0.75, there's 1%, 1.5, 0.75, 0.8%, and 723 is about there. 900 comes down there, 1150 is probably about there actually. And it's somewhere between 1.5% and 2%. I've seen it in lots of places inside a text. So let's say it's, there you go, I'll call it 2% or thereabouts. That's that one. And that's the austenite phase range. That's the face-centered cubic. That's where it's body-centered cubic. Now let's just draw these to scale now. 0.5, 0.25, 0.1. There you go. 0.3, it's a 5/10 of nothing. You can't really see that when you draw it to scale. Essentially assume that's a 0 when you're doing your phase diagrams. Just know there's a tiny bit of carbon in solution. Tiny, tiny bit. Most of it down here becomes iron carbide. So steel is weird because it forms a natural ceramic inside the steel as it cools. The natural ceramic. Let's have a quick look at what it is. Let's have a look at that high temperature phase. There's 723 degrees C. There's 900. As it cools, there's 0.8%. That is pure 100% face-centered cubic austenite. Down the bottoms, 100% of the iron is body-centered cubic ferrite. In between is a mix of ferrite plus austenite. As you cool the steel down, it changes from being austenite to ferrite. It takes a little bit of time to change for some of it. At the boundary, and this is a completely different video, at that boundary it changes. And then below that 723 degrees, it's all ferrite. Austenite takes lots of carbon in solution. When it gets to 723 degrees, it's holding 0.8%. So there it's holding 0.8% carbon solution at 723, 724 degrees. When I cool it down to 715 degrees down here, it's got
0.03%.
Tiny amount. 0.8%?
96%
less. All that extra carbon's got to go somewhere. So that goes to ferrite plus iron carbide. That's a 3. Ferrite plus iron carbide. It makes a natural ceramic.